Hi everybody, in this section we want to look at polynomial and rational inequalities. So this will be sort of similar to what we did in the last section, except you won't have an equal sign for the rational equation, you'll have some sort of inequality. So let's look at solving polynomial inequalities. And we kind of did this back in the last chapter in the last section of chapter 4, where we were solving quadratic inequalities. If you remember, we basically determined where the cut points were, and then we did a sign chart. So this will largely be the same, except again, we're not necessarily dealing with parabolas. And there are a couple different ways you can do this, like we did in that section. For example, one way you could solve a polynomial inequality is to graph it. So let's say, for example, you have this polynomial inequality, right? This side is a polynomial. You have a less than sign here, so it's an inequality. You could solve it by just simply graphing the curve, and you could just look at it, right? So we want to know this is basically saying when is the height of this curve less than 0? In other words, when is the height negative? Well, it'll be negative in this region, right? And then it's above the x-axis everywhere else. So the solution to this equation, or to this inequality, then would be x is less than -1, or you could say it's negative infinity to -1, right? The graph is going to be below the x-axis. It'll have a height below 0, in other words, when you're to the left of -1. Now that presumes, of course, that you can graph this, and again, that can be kind of difficult. I guess we did talk about this in the earlier sections of chapter 5, so it's not like we haven't done this. But again, it is kind of difficult to do that. Again, if you're allowed a graphing calculator or something like that, you might be able to do that. But again, especially for those of you going on to take calculus, it's possible that you may not be allowed to use a graphing calculator in that class. So you really do want to be able to do these inequalities without graphing if possible. So let's look at the guideline for solving polynomial inequalities algebraically. So what you want to do is you want to basically move all terms to one side of the inequality. So in other words, basically make one side 0, like we did here. So in this case, you don't have to do anything because it's already 0. And then factor the non-zero side. Now in this case, this side is already factored, so we don't have to do that. And then make a sign interval table, just like we did at the end of chapter 4, and then determine where the inequality is positive or negative using the zeros that we found from factoring. And then you solve the inequality by looking at the result of the sign chart or sign interval table. So let's look at an example of that. So let's say, for example, we wanted to solve this inequality. So this is a polynomial inequality. So what you'd want to do is make one side 0, so subtract x from both sides. So again, make one side 0, then factor the non-zero side. So you can factor out an x, and then this might be a little tricky here. In order to factor the x cubed minus 1, you'll have to use the formula that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And again, that might be sort of an obscure formula you might have seen in your previous algebra classes, but in this case, if you think of a as being x, and if you think of -1 as being 1 cubed, you should be able to factor that into x minus 1 times x squared plus x plus 1 squared, which is just 1. And you'll notice there's no 2 in front of the AB, so don't confuse that with the other formulas there. So factor this, and then figure out where the graph is going to touch the x-axis, right, where the x-intercepts are. So one of the places that will make this thing 0 is if x is 0. Another one that will make this side 0 is if x is 1. And then if you try to solve this equation here, you'll see that you'll get complex solutions. So the only place where the graph is going to touch the x-axis is at 0 and then again at 1. And then, so what you'd want to do then is use your sign chart. So we'll make a sign chart here. We'll make a cut at 0 and then a cut at 1. And then determine what's happening to the height of the function on either side of that. So pick some number that's less than 0, say for example -1, and put it into this factored form. Again, you can put it into the original form if you want, but let's say for example you choose x is -1, right? Then you'll get -1 to the 4th, which is going to be a positive 1, and then you'll get minus a negative 1, which will be a positive 1, so the height here should be positive. Alternatively, you can put it into this factored form. If you put like a negative in here, for example, this will be negative, that'll be negative, and this will be positive, so you'll get a negative times a negative or a positive here, right? Pick some number between 0 and 1, like say 0.5, and put that in for x, so you'll get a positive here, positive here, and so this will be negative. And then finally pick some number bigger than 1, like say x is equal to 2 or 3 or 3,000, whatever you want, as long as it's bigger than 1, and put that in, and then you'll see that over here you should get a positive, right? Because you'll get a positive number times a positive number times a positive, so the height here will be positive. And again, if you look back at the inequality, right, I mean, so I guess we're looking at solving this original inequality, but if you look at this one, right, we're trying to find the values of x that will make this thing, the height of this thing, greater than 0. So what sort of things are greater than 0? Positive numbers or negative numbers, right? That would be positive numbers. So in this case, what you'd want to do then is pick the place where the intervals are positive. So that would mean you'd want x, as long as x is any number between negative infinity and 0 and 1 to infinity, it should make this thing positive, which in turn should make x to the 4th greater than x. So let's maybe look at another example here. So let's say you have something like this. So again, what you'd want to do is move the 6 over to the non-zero side, factor this. So your cut points in this case would be at x is equal to negative 2 and x is equal to negative 3. Then check and see what's happening to the sign on either side of those numbers. So for example, if I pick, say, x is equal to negative 4, and I put it into the inequality, and it's usually faster to put it into the factored form. You can put it into the non-factored form if you want, but if I put a negative number, negative 4 in for x, this will be negative, this will be negative. So negative times a negative will give you a positive. Right? If I pick some number between negative 3 and negative 2, say for example negative 2.5, this will be negative, that'll be positive, so the height of the function will be negative here, or below the x-axis. And then if I pick some number to the right of negative 2, like say x is equal to 0, I'll get a positive 2 times a positive 3, so the height here will be positive. And then again, look at your original inequality, right, where I'm trying to figure out things that will make this greater than or equal to 0. So again, that would be the positive regions again. So that would be the solution in this case would be everything from negative infinity to negative 3, and then from negative 2 to infinity. And that will also be a solution to the original inequality. I guess another way you could also look at this is you're sort of asking, when is the graph of x squared plus 5x have a height greater than negative 6, right? And if you think about this one is again is a quadratic inequality. We did these back in the last chapter, but so you could also think of this as sort of a parabola that opens upward if you think in terms of the original inequality, and you're looking at what values of the function will make the height of the parabola greater than height negative 6. That's another way to look at it. Or alternatively, you could ask what values of x will make the height of the function greater than 0. So I guess I got the slides in the wrong order. Here's the last part of the last problem we did here. So so you can see that we did get the right answer here, right? If we have should get a negative infinity to 0 and 1 to infinity, right? Which is again what they got, and these are the numbers that they chose for their sign chart. Again, you can kind of use whatever you want there, right? You don't have to necessarily use the same numbers. So then what we want to look at is solving rational inequalities. And so, that would be something where you have a polynomial divided by a polynomial and an inequality. And so again, you can do this a couple different ways. You can do it graphically, like this. So again, we're trying to solve this inequality. So you could try to graph the left-hand side, right? And we just talked about that in 5.3 about how to graph these sorts of things. So I'm not necessarily going to go through exactly how you would graph this, right? But you'll have a vertical asymptote at 3 and negative 3, because if you factor the bottom, it'll factor here into x minus 3, x plus 3, if you factor the top, it'll factor into x minus 2, x plus 2. So you'll have x-intercepts then at negative 2 and 2. And then the y-intercept will be when x is 0, which will give you a positive 4/9. And then you can just do a sign chart to see when the height of the function is above the x-axis or below the x-axis. Look at the horizontal asymptote, which in this case really doesn't matter, right? You're basically just trying to figure out where the graph of the function is greater than 0. So in a way, it's a little bit extra work to do this, so there's really no reason to do it, but that is one way you could do it. But since you have to do a sign chart when you're graphing this function anyway, at least if you're doing it without a graphing calculator, you might as well just do the sign chart and not draw the graph. But I guess if you are ever allowed to use a graphing calculator in something like this, the quickest way to do it would be to just input the inequality into your graphing calculator, just graph it and look at it and see where's the height of the function above 0, right? So it's above 0 here and above 0 here, so the solution then would be negative infinity to negative 3, again from negative 2 to 2, and because you've got an equal sign underneath here, right, it does include negative 2 and 2 because the height of the function is 0 at x is equal to 2 and negative 2, and then greater than 3. Now again, since you're really going to have to do that, do the sign chart anyway when you're graphing it. So this is basically just a simplified version of what you might have done in the last section. But what you want to do again is you move all terms to one side of the inequality, right? Don't multiply both sides by the denominator unless you're sure that it's positive for all values of x, because if you remember for inequalities, if you multiply both sides by a negative number, it'll flip the direction of the arrow or the inequality there. And then basically try to figure out where the top and bottom of the polynomial or the rational function is 0, and then make a sign interval table using the answers to where the top and bottom are 0, because the rational function can basically only change from being above the x-axis to below the x-axis at those values, and then you solve the inequality again by either looking at the positive values or negative values depending on what you're looking at. So let's look at a particular example. So let's say, for example, we want to solve this rational inequality. So again, do not multiply both sides by x plus 2, right? Because again, if for some values of x, the bottom is negative. So what you want to do in this case is move the negative 3 over, and then basically add these two fractions together. So I have to multiply on the top and the bottom by x plus 2 here to get a common denominator. So then add the numerators together, and you'll get this inequality. Then basically figure out where is the top and bottom 0. So the top is 0 at 1, the bottom is 0 at negative 2, and then basically construct a sign chart, again, where you use 1 and negative 2 as your critical values or cut points. So then basically pick some number in each one of those intervals, right? So you've got your cut points here. Pick a number to the left of negative 2, like say, for example, negative 3. Pick some number between negative 2 and 1, like say, for example, 0 is a good one to pick. And then finally pick some number to the right of 1, like say, for example, 2, and plug that into your function and see whether it makes it positive or negative. Now, you don't actually have to evaluate the function. You could just kind of look at the inequality and say, let's say, for example, if I pick negative 3, the top's going to be a negative 4 and the bottom will be negative. So the negative divided by negative, which will give you a positive there, in this case in particular a positive 4. So, and again, the only place that the height of the function can change from being above the x-axis to below the x-axis is basically at the x-intercepts or wherever you have a vertical asymptote. So if it's positive for any value to the left of negative 2, right, it has to be positive for all values there. So the height of the function has to be above the x-axis to the left of 2. The height of the function has to be negative between negative 0 and 2, and then it has to be positive again to the right of 1. Or sorry, I meant to say between negative 2 and 1 there. In this case, right, if you look at the original inequality, well, not the original inequality, but the inequality where we got one side 0 here, right, you're trying to pick things that will make the height of this function greater than or equal to 0. So by answering this, that'll help us answer the original inequality. In this case, right, so you'd want to pick positive regions in this case, right, which would be all the numbers from negative infinity to negative 2, and then again from 1 to infinity. And because we do have an equal sign underneath here, right, we'd want to include 1. Now we would exclude negative 2 because it's not in the domain of the function. Right? So it is important to make sure you check your endpoints there. So here's another example. So let's say, for example, we wanted to solve this inequality. So again, rather than multiplying both sides by x minus 3, remember what you'd really want to do here is move the 2 over, right? And then just like the last example, we want to add the fractions together. So multiplying the top and the bottom here by x plus or x minus 3, right? You'll get this. Then simplify the top, so just distributing and combining like terms, I'll get 2x plus x, that'll give me 3x, and then I'll get negative 6 plus 1, which will give me negative 5 over x minus 3. So in other words, the places where you'd want to make your cut points, then again, wherever the top and bottom is 0, so in this case the bottom is 0 at x is equal to 3, and the top will be 0 at x is equal to positive 5/3, right, which is somewhere over here. Right. Then pick a test point in each region and see what it does to the sign of the function here. So if I pick some number to the left of 5/3, like say for example 0, right, I'll get a negative 5 and a negative 3, so the height of the function will be positive here. If I pick some number between say 5/3 and 3, like so for example 2, the top will be positive, the bottom will be negative, so the height of the function will be negative here. And then finally pick some number to the right of 3, like say for example x is equal to 4, both the top and the bottom will be positive. And again, in this case, if you look at the inequality, we're trying to find things that will make this, again, greater than or equal to 0. So in this case, that would be all the numbers from negative infinity to 5/3, including 5/3, because it does make the function 0, it makes this 0. And then also everything from 3 to infinity, but we do not want to include 3 because it's not in the domain. And then another way you could sort of verify this, I guess, is graph the function and look at it. And you can also, if you want to be extra sure, you can't really check this like an equation, but you could pick some points in each region and see if it, if it actually satisfies the inequality. Because remember, what we're ultimately trying to do is try to figure out, well, what numbers could I pick in for x, pick and put in for x that will make this side greater than negative 2. And here's the graph of that function, that inequality. And so in this, the right-hand side is just the graph of x plus 1 over x minus 3. Here's y is equal to negative 2. So you can see the height of the function is positive for all these numbers in here. And then it's above negative 2 for all these values here. Here's another example. So in this case, let's say you want to solve this inequality. So this one already, the right-hand side's already 0, so all you have to do is factor the non-zero side. So I've already factored it here. And then just pick a test point in each region, right? Your cut points will be at 2, 1, and then at negative 4/3 somewhere over here. So pick a test number in each region, like pick negative 2. That'll make the inequality negative, right? Because you'll have a negative times a negative divided by a negative. So height will be negative here. In between 4/3 and 1, pick 0, for example. That'll make this positive, negative, negative. So the height of the function will be positive here. Similarly here, between 1 and 2, pick some number. That'll make the height of the function negative. And then finally pick some number to the right of 2, like say x is equal to 3 or 4. All these factors will be positive. So this fraction will be positive. And then again, pick the regions that solve the inequality. So you, again, in this case, you want to pick the regions that make the height of the function greater than or equal to 0, which in this case would be all the numbers from 4/3 to 1, including 4/3 and excluding 1, because 1 is not in the domain there. And then also from 2 to infinity, including 2. So again, you're basically doing the same thing for all these problems, right? You're basically just going through the procedure that I outlined earlier, which is mainly, make one side 0, and then factor the non-zero side, figure out where the top and bottom are 0, and then just make your sign trick. So maybe just to look at one more example here, and then here's a graph of the function. If you graph the left-hand side, you could just look at it here. So the height of the function is positive here to here, and again it's positive from here to here, which matches what we got, right? 2 to infinity, and then 4/3 to 1 more. Let's maybe do one more here. So let's say you wanted to solve this inequality. Again, in this case, your cut points would be at -2, +1, and then +7/2, which would be somewhere over here above 3, right? Pick a number for each region and see what you get. So now in this case, this particular part is always going to be positive because you're squaring, so it really doesn't matter. So all we really need to do is look at these parts. So pick, like, say x is equal to -3. This will be negative here. The bottom here will be negative, so the height of the function is positive there, right? Pick some number between -1 and 1, like say x is equal to 0. You'll get a negative on top, positive on the bottom, so the height of the function will be negative here. Pick some number between 1 and 7, like say 2. The top will be positive and the bottom will be positive, so that'll be positive there. And then I'm sorry, I guess the top will be negative there, right? Sorry, if you put in 2, you'll get a -3 on the top, right? So that'll be negative. And then finally pick some number greater than 7/2, like say 4. You'll get a positive divided by a positive, which will make the height of the function positive there. So again, normally these signs will alternate positive, negative, but not always. So again, be careful and make sure you check each region there. So again, we're looking for the solutions, the values we can stick in for x that will make this inequality greater than or equal to 0. So that would be everything from -infinity to -2, excluding -2 because it's not in the domain, and then again from 7/2, which again you'll include 7/2 to infinity. And again, you can look at the graph of the left-hand side there if you want. If you look at the graph, that matches what we got, right? So we said it was above the x-axis between -infinity and -2, which it is here. And again, this is only part of the graph. It actually continues on forever here and goes above the x-axis. And then again from 7/2 to infinity, which again would be somewhere over here. So it's going to pass through the x-axis here at about 3 and then go above the x-axis there. Maybe not a very good graph there, but now there might be some other inequalities that are a little bit more difficult, like say for example the next one. For something like this, again, you don't want to just multiply both sides. So what you'd really want to do for an inequality like this is move everything over to one side and then add the fractions together. And I'm just going to factor the bottoms while I'm doing this. So I'm going to move this term over to the other side, and then I got x minus 5, x plus 5. That'll be greater than 0. And then just add the fractions together. So here I'll have to multiply on the top and the bottom by x minus 5, x plus 5. Here I'd have to multiply on the top and bottom by x minus 5, x plus 5. And then same thing over here, right here I'd have to multiply by x minus 3, x plus 3. Here multiply by x minus 3, x plus 3, and then just add the numerators together. So I'll get 4 times basically x squared minus 25. And I'll get minus 3 times x squared minus 9 if I FOIL that out. And then that'll be all over the common denominator given by all 4 factors there. Right, and then this will be greater than or equal to 0. And then go ahead and distribute the 4 through, right? So you'll get 4x squared minus 100 minus 3x squared plus 27 all over the common denominator. So these can take a while. I don't know if there's too many of these in the homework, but there might be a couple. And then just combine like terms. So 4x squared minus 3x squared will give you x squared, and then you'll get negative 100 plus 27, right, which will give you minus 73. And so your cut points in this case would be wherever the top and bottom are 0. So in this case it would be at 5, 3, negative 5, negative 3, and then wherever the top is 0, so that would be the, I guess, plus or minus the square root of 73, which, if you think about that, right, the square root of 73 is going to be somewhere around 8 something, so somewhere over here. So just pick a test point in each region and see what you get. Now just to speed this one up, I did graph the inequality here. So you can just kind of look at it here, but again, pick a number in each region here and see what you get. Like, say, for example, if you pick x equal to 0, right, the top will be negative, and then you'll get a negative here for this factor, positive for this factor, negative for this factor, and a positive for this factor. So you'll have 3 negatives, which make the height of the function negative there. And if you look at the solution here, again, I didn't graph this function, but I graphed these as 2 separate functions. You can just kind of look at it and see where that happens. So in this case, this function here is above the other one on these various regions here. So that would be another way to look at that one. So just to look at summarize this, the steps for solving polynomial and rational inequalities are basically to make one side 0, and then basically determine where the top and bottom is 0. Now remember, for polynomial functions, right, you won't have a denominator. And then make a sign chart, and then determine where the function is positive or negative, and then what answer the question based on what the original problem is asking. So I hope that helps. If you guys have questions about anything or whatever, just let me know.